Hi there, I'm Eitan, and welcome back to Wix Wiz. Today I'm going to be talking about a hidden gem of the OpenAI API that's been kind of overshadowed by the whole ChatGPT craze. But this is actually something that, if you understand, it can help enhance your ChatGPT bot in the future. What I'm going to be talking about is semantic search using OpenAI's embeddings endpoint. And what we're going to be doing is creating a database that can be searched based on meaning and not by matching up some kind of keyword. So for example, if I go over here and I search, I have dirty teeth and click search, then it's going to search my database based on meaning and come back with electric toothbrush as the first result. Even though you can see here that there's no mention of teeth or dirty anywhere inside of this entry over here. And the way I'm going to do this video is first I'm going to talk a little bit about how classic search works and what the downsides to that are. Then we're going to talk about how to get a vector for a string using the embeddings endpoint, and then how to map our database using vectors and essentially complete this query using vectors. So if you want to learn more about semantic search, OpenAI embeddings, and just how to improve your user experience for search in general, let's get started. So before we get into vector databases, embeddings, and how to build that out, let's talk a little bit about what the issues are with traditional search and what we're trying to overcome by using a vector database and embeddings. So what I've done here is I've set up a very basic search console here. So we have a input to enter our search query, we have a button, and we have a repeater which will list the results from our search. And basically what we're going to be doing is we are going to be searching this database that I set up over here. So I called it plain database. And what I did is I built out kind of like mock products. Again, this could be anything that you're trying to search, any kind of database. And each one has a title. It has a plain text description, and I also set up some keywords. And this is kind of how you would build out a traditional search. So we're going to build the ability to search either in the title or the description, or to see if we have a match for any of the keywords. And this is how we'd build traditional search, and we're going to see what some of the issues are with this search method. So let's go ahead and dive into writing some of our code. So what we're going to do over here is I'm just going to name some of these elements that I put out here. So this will be our search input. This will be our search button. Sorry if you can't see so well because I'm blocking. It's our search button. And right over here, we're going to have our results repeater. And here we're just going to have the result title, and we're going to have our results description. Okay, so we're going to try and search our database for all the relevant results and display them here in our repeater, just to simulate somebody who's searching for a certain product, let's say, or a certain piece of information, and we want to display it over here inside of the repeater. So first thing we're going to do is build out the function that will run when we click search. So I'm going to go over here. Let me zoom in a little bit. Excellent. And I'm going to select the search button, on click. And when we click, we're going to run a certain function. And I'm going to build that function over here outside of the search button. And I'm just going to say const search. And this will be an asynchronous function because we're going to be querying data, etc. And while we're at it, let's go ahead and import Wix data because we're going to need that to do some of the querying. And when we click the search button, what we're going to do is we're actually going to go ahead and run that search. So let's think about what we want this search to do. First, we want it to get our user input. So we're going to get user input, and that will be equal to the value of our search input. And then what we're going to do is we are going to start and see if any of the fields in our database contain this user input in any way. So there's several ways that we can go about it. So I'm going to build out several queries here. So let's start with const title query. And what I'm going to do is I'm going to say wix data dot query, and the collection that we're going to be querying is called plain database. So that's just like this, plain database. And we're going to see if we have a title that contains our search query. So contains title user input. Okay, so that's one thing that we can check for. Another thing that we can check for is if our description contains the user input. So description query, let's call it. And that will be wixdata.query. And again, we're querying this same plain database. I'll just go ahead and copy that right over there. And we're going to have also contains description user input. Okay, another type of query that we can do is to break up the user input into an array of strings and search as well. Because if we search just using user input, so if they input, let's say, quite a long sentence, the chances of us matching the description is pretty low. But if we break each one of those into an individual word and search for those words within the description, then we have a higher chance of getting a match. But then again, we also have a higher chance of getting a miss. For example, if they put in the word the, and I'm checking the description for the word the, then high chances that we'll find a match for that. So we'll also need to create some words that we're excluding from search. So let's go ahead and create that array. So const user input array equals, I think this is array dot from user input. I think that's how it's done, and I'm going to check that out in a moment. And then we can also create another query here, which will be const description description query. Let's see, description. Let's say description contains query. Sorry, contains. What did I name this? Description query 2. Very original. I just don't want to waste time on naming things. Wix data dot querying the same database, and we're using instead of contains, we're going to use something called has some. So basically, it checks to see if the description query has any of the values that are in, for example, an array. So here we have description again, and we have our input user input array. Excellent. And one more query that we can build out is our keywords query. So const keywords query will be with data dot query, again, plain data set, and then has some keywords, title, what did I call it? User input array. Okay, so the difference here between the keywords and the description is that, let's say our description is just a plain text description of our product, but let's say we also know of some keywords that are related to our product but aren't included in the description of the title. So we can kind of enhance our search by giving some kind of metadata about our product and helping our search engine find it even if it's not included in our description. Okay, so that's the advantage of having keywords here. The disadvantage of has is that it's case sensitive. So contains is not case sensitive. So that means even if in the description something is capitalized, but in our user input it's not, it'll still find it. But it has the downside of looking for an exact that exact string. So not part of the string, but that exact string. So for example, if the user inputs a blue hat, the description will have to have a blue hat in a row. It could be capitalized, it could be not capitalized, but it'll have to have that exact string. Whereas here we're kind of looking for or a, or blue, or hat, but it will have to be either capitalized or not capitalized, and the same goes for the keywords. Okay, so those are just some disadvantages and advantages of how we're building out our queries here. And then I'm going to put all of these queries together. So I'm going to say const query result equals Wix data dot. Sorry, we don't even need Wix data here. We could just do title query dot or description query dot or. And remember, dot or is inclusive, so that means that if any of these match, then we're good to go. Then that's considered a result. Whereas and would be exclusive. So if we needed and, that means also this query would have to match, also this query would have to match, and that's definitely not what we want. So here we're going to have description query 2 and add one more dot or for keywords query, and then I'm going to go ahead and try and find that. And then const results equals query result dot items. And for now, I'm just going to go and console dot log results. Before we start putting it in a repeater or anything, let's just check and see if this is working in any way. So I'm going to go ahead and test this out. So let's just look at our collection. So here, plain database. So I just want to take some keywords here that I know that we have. Okay, so we have a portable power bank. Okay, so let's try and hit that portable power bank. So I'm going to go ahead here into preview. And I'm going to say portable or portable power bank. And go ahead and click search. And my query is not even running. So let's go ahead and see what's going on there. So let's add some more consoles here. So I'm going to console.log user input. And I'm going to console.log user array just to see if we're getting any issues over there. And I am going to make sure we named everything correctly. Search input, search input. Let's move these a little further away so that they're not covering each other in preview mode. And I'm just going to change the design of this so that it's an input that you can actually see. Where's design here? The zoom in a little bit. Okay. Can I change this to an input where we can actually see the text here? So let's see. Just change the font to something else. Excellent. Let's go back and zoom in. And I'm going to go back into preview. Oops, I forgot to close that side panel. Excellent. Zoom in, preview mode. And let's try searching again. So portable, what do we say? I'm just going to look for power bank. Power bank. Let's hit search there. And okay, so we got back power bank. Okay, so this is not what I wanted because it kind of gave me an array for each letter, which is not what I want at all. So it's good that we checked out. So what I actually want to do, I think, is maybe use split. User input dot split, split. And then the separator will just be space. So if there's a space between the words, then it'll split that up. But still, our query should have technically worked, even though query results. Let's try it again, just to see that our array is working correctly. So I'm going to go ahead and search for power bank. Okay, so this is exactly what I wanted. So we split up the array based on into two words. But my query style is still not working. So what I'm going to do here is I'm going to run this in a try catch. So we can see if we're getting any errors here with our query. So I'll go and put this over here. And then here, sorry, over there, I'm going to put it in the try. And then here in the catch, I'm going to say console.log error. Let's try that out. Power bank, and go ahead and search. Query for the same collection only. Oh, did I call it different collections? Let's see. Oh, here I called it plain data set, and here I called it plain database. Okay, so let me just copy this over here. And let's try that again. Preview, power bank, search results. And we got one result, which is our power bank. Okay, so that worked pretty well. But let's try a slightly longer sentence. So let's just try go into preview, and I'm going to search for a power bank that I can hold in my hand. Go ahead and click search, and in the results, we didn't get back anything because this is a rather long sentence. And if we go back into site, so description has some. So it could be that I'm using has some incorrectly here. So let me try and see for a second. Velo reference has some. Let's take a look here at the Velo documentation. Zoom in a little bit. Has some. Refines, it's case sensitive. Specified property contains multiple reference pass IDs. Specify a list of values to match, providing an array of strings, numbers. Okay, so I think this is what's happening here, is that what it's doing is it's trying to match the description as an exact match to each one of the things in the array. So it's trying to see, does the description match just the word power? And obviously this is not the case because the description is very long. So I'm going to change this actually to a contains. Okay, so instead, but here I can't use, then I can't use the array here. So that's one of the issues here with querying, just using, a plain search. It's very hard to search the description, let's say for specific keywords. And what I would have to do is, let's say, either take my entire description and split it up into keywords to do that search. Or yeah, that's pretty much what I would probably have to do. But basically what I'm trying to show now is some of the struggles that we encounter with classic search. So I think this is a perfect demonstration. Um, yeah, so let's just go ahead and try this again. So I'm going to go, and now what I'm going to try and search for is something that is in the keywords. So if I go here to the collections, let me just check what we have in the keywords here. So let's say, okay, lightweight. And I don't think I have that here in the description. Oh, I do have lightweight. See if I have high capacity. I don't have high capacity. Yes, I do have high capacity. Let's see. Fast charging, USB ports. Okay, I don't have USB ports. So let's look for USB ports. But I don't know if that will work because it's 2 words. So let's just change this to USB. And now let's go ahead and run a search. I go back into preview mode and search for, let's say, USB. Make it capital, USB, and go ahead and click search. And we get one result back because we got a match here on the keywords. But you could see already the struggles that we're going through in order to get a match on these things. Okay, so it's quite challenging to set up search, and also the accuracy is quite low because if we didn't hit it in our keywords, or if we didn't hit it inside of inside of our description, then we're not going to be able to find that thing. And basically, that leads us to what we're trying to talk about today, which is the semantic search, the use of vectors and embedding. So semantic search basically means is that instead of looking for a match on a specific word or word combination, we're going to be looking for a match in meaning. Okay, so we're going to set up a database where we have a representation of the meaning of each of these, and we're trying to match that meaning to the meaning of our search term. So let's talk a little bit more about that. So if we go here to this document here, which introduces OpenAI's embedding endpoint, they explain a little bit about how these vectors work. And basically, we take or not we, but OpenAI will take a certain string and it runs it through the embedding model and it turns it into a vector. A vector, which is for our purposes just an array of numbers. And then these vectors basically arrange words or strings inside of a space, a virtual space, where the strings that have similarity in meaning are closer to each other. So you can see also a 3D representation of this over here. So we can see that, these different things here are, this person from Japan is related to this person because they're both doing sports, I think, or something along those lines. And these are all related to military concepts, etc. I'll link to this documentation below and you can take a look, but basically different texts with similar meanings are grouped together inside of this space. So basically what we can do is we can take our database and we can assign each entry in our database a vector using OpenAI embeddings. And then we can also turn our search term into a vector. And then we can compare the similarity between the two pieces of text using something called cosine similarity. And again, this isn't going to be a math lesson, so I'm not going to go too deep into what cosine similarity is. You're welcome to check out the Wikipedia explanation of this. And this is basically the function that we're going to be using. I know it looks really complicated, and we're going to ask ChatGPT to help us create a function that will do this basically. And just to sum it sum it up, what it does is it compares the two vectors, and it comes out with a number between 1 and -1. Where does it explains it over here, I think. So it results in a similarity range from -1 to 1. So -1 would mean exact opposite, and 1 would mean exactly the same. And then we are going to determine a certain threshold within which we are going to accept this as a match. So let's say I can say, okay, if it's an 0.5 match, then this means that these are matches and I want to display it in my search result. Or I can set a different threshold. I'm not familiar with any specific rules as to what is an acceptable or unacceptable threshold, but we can do some experimentation by ourselves and try and figure that out. So let's do a demonstration of this and talk a little bit about how we're going to get those embeddings and just make everything more clear by example. So I'm going to go ahead back to our site, and I'm going to go into our backend files, and I'm going to create a new one for embeddings. And here we're going to be using an OpenAI endpoint. So let's go ahead and import not Wix data, but import fetch from Wix fetch. And import get secret. I already went ahead and stored my API secret in the secrets manager, Wix secrets backend. And we're going to create a function. This function is going to be const create embedding from, which will be equal to an async function. And here we're going to write out our code to call that OpenAI endpoint. Let's take a look at the OpenAI documentation for embeddings. And here they kind of explain a little more in detail, what these embeddings are, what they can be used for. And here is the explanation of how to get embeddings. And there are several models here as well. And they recommend using embedding ADA 002 for almost all cases. So that's what we're going to do. I'm going to take their recommendation, and we're going to set up a simple call here to the embeddings endpoint. So I'm just going to copy this over here. It's also worth taking a look. This is the guide, what I'm looking at over here. You might also want to take a look at the API reference itself. So the API reference here, and then down over here, we have embeddings. Okay, so this is what we can use. And this also talks about the parameters that it takes. Same. So we're using this endpoint over here. I'm just going to copy that over to our backend. So const URL be equal to this. And in terms of our API key, so I'm going to say const API key will be equal to await get secret. And I called this API key, let's see, I think I have it over here. Developer tools, secrets manager, OpenAI API key. See that over there. And then we're going to have our options. And we're going to have, let's take a look, documentation. So in terms of, we're going to have two headers. So we're going to have authorization and we're going to have content type. I'm using just copying from the curl here. You can also choose to use this Node.js package. I personally just like fetch. It's a personal preference. So I'm going to go over here, and these are our headers. And I'm going to copy these two over here. Get rid of this, get rid of this. Add quotation marks here, and this is going to be a template literal. And here, instead of what we have here, actually I named it pretty much the same thing. I just need to add these squiggly brackets here. And note that these are backticks. I know a lot of people get confused in the tutorials, especially because it's kind of small. So these are regular ticks, these are backticks. Okay, so what I'm using here is backticks. And the content type will be application JSON, OpenAI, sorry, haha. Put in a variable that's called open API key, so that's what we're going to put here. And here we're going to comma. Okay, so that's for our headers. And in terms of the body, so it's going to be, let me declare the body outside of the options. So I'm going to say const body. And here we're going to take, oops, when I have the the OpenAI kind of logo on everything, it gets confusing. So we're going to take model and input. And I'm going to add this over here. And we'll start off just using as input their example. Okay, and then we're going to talk about how we can change this function so that we can use our own inputs for this model. And then what we're going to do here is we're going to pass the body into here as JSON.stringify body. Excellent. And now we just need to call this. So const response equals await fetch URL and options. And then const data will be equal to await response .json. And we're going to return the data. And now we pray that everything here went well. I'm just going to add the export keyword over here, and that will help us run this in the backend. So I'm just going to run that. And error. You must provide a model parameter. Okay. Let's see. I did provide a model parameter. Let's see if this is post or, yeah, okay, this is post. So let's make sure that I say that it's a post. So I'm going to say dun, 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 headers method. Method is post. I think it was trying to run it as a get before, which would need the parameters to be provided in a different way. So I'm going to go ahead and try that now. And we got it back. Okay, so we got back our data and we got back an embedding. And within that embedding, we have the vector representation of that string. And you can see here that it is there's a lot going on here. And if I give you, so I'm not sure exactly how they determine how many, elements there are to this vector. This is really going a lot more into, the whole how these API models, AI models are built, etc. So that's kind of a complex topic. But we're just going to take it as we get it. So we're going to get, we got our embedding back, so we're happy. And now what I want to do is I want to actually test it out and compare to embeddings with the cosine similarity to see if this is a real thing or not. So what I'm going to do is I'm just going to change our embedding function a little bit so that our input is passed over here. And instead of having the input here, we're going to have input like that. And the other thing I'm just going to return, instead of returning everything that we have here, I'm just going to return data, 0, embedding. So let's go check out data, 0, dot embedding. Embedding. Data, I think it was data dot data. Let's try that out. So I'm just going to refresh here. We need to give a parameter now. That's not working. Let's try this again. Run. Input. So let's just try the word cat. I'm going to go ahead and run that. And what we got back is just the embeddings. Okay, so this is what I want. Because we don't need all the other stuff, I just need the embeddings. So what I'm going to do here is let's set up another function over here. const compare. And this is going to be also async. And what this function is going to do is it's going to take two words. So let's say word one, word two, and it's going to compare their vectors. So in order to compare the vectors, we're also going to need a function that will do the cosine similarity. So let's go ahead and ask ChatGPT to write a function for cosine similarity. And it's going to be in Python, and I want it in Java. And the dot product divides with minus, you get a cosine similarity result. Okay, so again, just a disclaimer here. If you're kind of writing out a function that you have no idea what it's supposed to look like using ChatGPT, so you have to take this with a grain of salt. This could be incorrect. So there's no guarantee here that this works. And you can also go ahead and search things like, Stack Overflow or something like that for an example like this. Or you can try and understand the math behind it and write it yourself. What I'm going to do is I'm going to run some tests using this with words that I think should be either similar or dissimilar. And if I see that the results are coming out correct, I'm going to take this cosine similarity function as at least partially accurate for this demonstration. If I was using this code kind of in production or for a client or something like that, I would do a little more testing just to make sure that this is actually an accurate representation of cosine similarity. So I'm just going to go ahead and copy this code here. And I'm going to put this over here. And what we're going to do is, so we're going to say const word one vector, and that will be equal to await, what did I call this? Create embedding for word one. And then we're going to do the same thing for word two. Word two vector. And then we are going to go ahead and compare them. Okay, so I'm going to say const similarity equals cosine similarity word one vector, word two vector. Okay, and I'm going to return that similarity. And let's see. So I'm going to export this, and now we can play around. Word two vector. Excellent. So I'm kind of excited about this, to be honest. Let's try cat and lion. So I'm going to go ahead and run that. 0.849. Okay, so that's high similarity. So that makes sense. I think that cat and lion are two quite similar words. Let's go ahead and try cat and dog. Go ahead and run that. 8.6. Okay, so it thinks that a cat is more similar to a dog than a lion. Again, arguably possible, but let's try something that really cannot be similar to a cat. So let's try rain. 1.79. Okay, maybe because of raining cats and dogs. I'm not sure. Let me try and think of something even less similar to a cat. Let's try metal. Also 0.79. These are all coming out very, very, very similar. I thought there would be less similarity between some of these words. Let me try and see another word. So let's say red. So it could be that the similarities are rather high between single words because single words are easier to overlap in meaning. Let's try and giving slightly longer strings and seeing if that, you know, clarifies this. So I love cats. Gold is a rare metal. And let's see, I don't think that there's a lot of similarity between these two strings, but let's see what it thinks. So I'm going to go and clear our outputs for now, and let's try running that. 0.75. Okay, so that's still rather similar. So I'm back from my short digression there, and I was just trying to figure out why everything was coming out so similar. And I came across this very interesting kind of set of posts here on the OpenAI community forum. And other people were also expressing similar sentiments about how similar the results they were getting were. And they all seem to be kind of in the upper, like above zero point 0.7. So things that you might expect to be opposites might be closer to zero point 0.7, whereas things that are more similar might be in the higher range, like zero point 0.8, etc. And it really doesn't get to the point where it's something is -1 or 0, like you might expect. And there are different theories going on here for why that might be. It could be because really this is based on a huge collection of data and just different ways they do the clustering. There are also some people suggesting trying to use something called Euclidean distance and not the cosine similarity. I ran some tests with it. It didn't seem to give a much larger range than the cosine similarity. And since cosine similarity is the recommended method from the OpenAI documentation, I'm going to stick with it. But I'm also going to try and explain why it's not such a big deal that these are coming out quite similar and the range is rather small. So let's say we're talking about a case here where we have a database with a lot of entries, and we are looking for the search results that we want to present. So essentially what we need to look for are just the most relevant search results. So for example, if I run all of my database through this cosine similarity, and then I find, let's say, the top 10 matches, I can present them even though, you know, I don't have to use, um, a certain threshold, like I said before. So let's say if it's above zero point 0.5 similarity, display it. I can just get all of these similarities and then display them in order. So for example, if we let me try and create a function here which will demonstrate that. So let's say we have the search query, and then we have word 1, word 2, word 3. And then what we're going to do here is we're going to say const query vector is equal to the embedding of the query. And then we're going to have for, and I'm doing this very crudely. Obviously, this would probably be an array if I was really working hard and creating a function here, but I'm just trying to demonstrate my point. Okay, so we have all of those. And now what we want to do is we want to say, we want to get the similarity of each one. So let's say similarity 1. Maybe it really would be better if it was an array. So I'm just going to put these in an array. Let's say array, just words. And these words are going to be an array. And then I'm going to say um, for let I equal 0, I is smaller than, I always do this wrong. I is smaller than words dot length, I plus plus. And then what we're going to do is we're going to say const, um, call it word vector equals to, and then here we're going to have the create embeddings for words I. And then what we're going to do is we're going to have const similarity equals to cosine similarity of query, because we're comparing them all to the same query. And we're going to have here the words. Word vector, and here we're going to have queries. And then what we're going to do is we're going to store, let's say, all of these in an array. So I'm going to say const rankings. This is going to be an empty array, and then I'm just going to push the similarity into the rankings array. So rankings dot push, and then we're going to do a similarity. And get rid of this. And instead, we're going to return here rankings. But before we return rankings, what I want to do is I want to order the rankings. So I'm going to do rankings dot sort. And let's say A, B, A, B. And then I'm going to do A minus B. Okay, so let's see what this does for us. So I'm going to go here and I'm going to run this. I'm going to refresh here. So we have our query. So let's say our query is cat, and then we have words here. So we have, say, dog, dog, book, apple, red, lion. Okay, and we're going to basically see what the rankings are for these words in comparison to cat. Okay, so let's go ahead and run that. So, oh, oops. Okay, so I organized the rankings here, but I didn't actually keep any record of what the words were. So that's a bit of a mistake. So let's go ahead and do that. So let's go ahead. Okay, so here, what I want to do is rankings.push. So let's push here. So let's say rank will be the similarity, and the word will be words I. Okay, so we could just have, we know which word is attached to which rank. Close this off. And why are we still having a problem here? Push. Hmm. Some kind of there's some kind of typo that I have here. It's not really helping me find it. Okay, push is closed correctly. Words I, it's fine. Any number. Oh, okay. So now the sort isn't really working because I added this. This is now an object and it's not just the rank. So this needs to be dot rank and this needs to be dot rank. Okay. I thought it was a typo, but it was actually a fundamental mistake. So let's go ahead here and I'm going to run this again. And now here we can see that from lowest to highest, we have peach, red, book, apple, lion, and dog. Okay, so lion and dog are the highest. They're the most similar. And peach and red are the most dissimilar. So that means that if I was now presenting search results, so let's say this is my database and I'm searching for cat, then I would present my search results in this order. So I would show first dog, then lion, then apple, then book, and maybe even I wouldn't include the last two. Okay, so even though our range is relatively low, it's very detailed. Okay, there's a lot of numbers here after the dot, so we can get a good ranking based on similarity. So this seems logical to me. Maybe arguably lion is more similar to cat than dog, but that's, semantics. Excuse the pun. Okay, so that's the basics behind this embeddings and create vector similarity, cosine similarity, and semantic similarity. So now what we want to do is we want to implement this in our database. And you saw here that it takes a lot of time to run something. So imagine we have a big database. So what we're going to want to do is we're going to want to create these embeddings for our database in advance. And that way, essentially what we need to do when we're running a search is just get the embedding the vector for the query, and then compare that using the cosine similarity, which is quicker than calling an external API. It still might be a little slow if we're doing a lot of comparisons, and that's why if you have a very large database, you might want to consider using one of these tools that is recommended over here. So there are specific tools that are built to be vector databases, and they query the database in a way that is, more appropriate than just using a Wix collection. But I think that using a Wix collection, in our case, will help us understand a little better how these things work behind the scenes, which is really what I'm going at. And I think that we'll see what the performance is like, but I have a feeling that if it's not thousands upon thousands of entries, then it should still be relatively quick. So let's take a look at how we're going to do this. So let's build out our vector database. So here I have a vector database, and I'm going to make it similar to our plain database. So what I'm going to do is I'm going to go and I'm going to open our plain database, and I'm going to copy over just the titles and descriptions. Technically, I could just build it here in the same database, but let's build it separate. So I'm going to copy this and go to our vector database. And I'm going to add here a text field for descriptions. And then I'm going to add in all of our products. And then I'm going to go and I'm going to add a new field for our vector. And this vector is going to be an array. And this is going to be the vector. Okay, and so what we're going to do here is I'm just going to run through this database, and I'm going to assign vectors to each of these products based on the description. Okay, not based on the title, because the description is longer. I'm hoping it could have more appropriate matches with more queries, but that's also something that's worth testing out. You might want to have several vectors. Let's say if you have a title, you have a description, you have a category, you might want to have a vector for each one. Just remember, this vector is a representation of meaning. So if these two things have different meanings, then you might want a separate vector for each one. That really depends on your database and your use case. I think in my use case, this is the way to go. So we're going to have vectors for these descriptions. So let's go ahead and write a backend function, which will just do that for us quickly. So I'm going to go here to embeddings, and I'm going to go to that. So I'm going to import Wix data here as well, import Wix data. And then let's say const assign vectors equals async. And then I'm going to have, let's query our collection. So I'm going to say const, what is it, vectors. It's complicated. So let's say database query equals await Wix data dot query vectors. See what I called it again. Memory loss. Collections vector database. database dot find. Okay, because we want all the entries here in the database. And then I would say const entries equals database query dot items. And then we're going to do entries dot for each entry. We are going to get the embedding for that entry. So embedding or vector, const vector equals to, let's use create embedding. Oh, wait, create embedding. And this needs to be asynchronous as well. And we're going to get entry dot description. Remember, dot description. And then what we're going to do is we're going to say, we want to add this to our entries. So what we're going to do, maybe I should change this to a for loop, because for each sometimes creates issues when you're trying to return something. Or I can just call update. I'd rather call bulk update. I think that'll be better. So I'm going to change this actually to a for loop. So let I equal 0. I is smaller than entries length. I plus plus. Oops. And get that in there. And then here we have entries I. And then I'm going to say entries I equals to, if I was being less lazy, it would probably be better to kind of create a new array for this, but I'm just going to overwrite our original array. So this will be entries I, and then here we're going to have vector as well. Okay, so we're going to add the vector to each of these items. And then here at the end, I'm going to call await Wix data dot bulk update. Now we're updating the vector database. And this is going to update with the entries. And I'm going to suppress auth just in case something there in my permissions would prevent this from happening. Excellent. So this should do the trick. Let's try it. So I'm going to export. If you're working with a live database on your site, you might want to copy it and do some experimentation with the function before running something like this on your database, because you can really screw things up if you get it wrong. But since I'm just kind of playing around here, and I have a copy, I actually do have a copy of this database, so it's not a biggie if I got something wrong here. So let me just run this. Not read property 0 of undefined. Let's see. So I'm going to go to property 0 of undefined. Query database stop find. So this is vector database. Let's console.log database query. Items are coming back. The items are coming back. So let's see where our issue is. 0 of undefined. Entries. Where do I have 0 of undefined here? Oh, let's. Let's see. Let's console.log console.log entries I. There might be a problem with the original embeddings function, but let's see. Entries, let's see, description. Um, okay, that's my problem. So there's no description. Maybe I spelled description wrong somewhere. Let's see. Content manager collection, vector database. No. Let's open the database itself. Descriptions. That's my bad. I should not have named with a plural here. By the way, I went the long way. You could also just check that out by going to right over here. Vector database descriptions. Could have done that. Anyway, put that over there and let's try running it again. So it ran through the entire function. And what kept on coming back null? That's kind of worrying. Let's see, what was null? Okay, because I had left it as description in the console. Anyway, let's check out our collection. Let's open it up. And we have our vectors. Okay, so we have assigned vectors to each of our things in the vector database. And now what we need to do is essentially just query that database and run the compare function that we did. Okay, so let's do some refactoring of our compare function. So we're going to have query, and then we're going to have, let's say, a collection. Or no, actually, let's have vectors. Okay, query and vectors. And then what we're going to do is we're going to get the vector for the query. And then for vectors dot length, we don't need to create the embedding for each vector because we're going to have them already in advance. So we're just going to need to run this with the vectors I. And then, but the question is, do we want, how are we going to get the original items back? Okay, so let's change that up a bit. Let's get items. So these are going to be items from a collection. And then we're going to have here items length. And this is going to be items dot vector I. And then here we're going to push the items. We're going to push the items I, and we're going to push in the rank, which will be similar. Why is this throwing me an error? Because I didn't put this in an object. So let me explain now what I am doing. So I'm going to pass into this compare function items from a collection. And I'm assuming here that these items will have a vector property. If not, this compare won't work. So I'm assuming they have a vector property because that's how I built out my database. And basically, we're going to query for the vector of, we're going to actually get the, sorry, we're going to get the vector of the query itself, thing that the user inputs to search for. And then we're going to compare that to our pre-made vectors from the collection, and then return essentially a list of the items with that added rank property. Okay, so let's try that out. So I'm going to go to the front end of our site, and here I'm going to import compare our backend session things. Okay, and then what we're going to do here is, instead of this old search function that we built out, I'm going to get rid of this, and I'm going to add the logic for the results repeater. So I'm going to add that above here. I'm going to say results repeater dot on item ready, and this is just telling it how to behave once it's passed data. So this is going to be item and item data, and then we're going to say that the item title no, what did I call it? Maybe a result title. Yes. Dot text will be equal to item data dot title, and the item for result description dot text will be equal to item data dot description. So very bad naming on my part. My bad. It should definitely not be plural there. Don't copy me on that one. Okay, so search, and what is this search essentially going to do? So it's going to say const query will be equal to user input, what did I call it? User input, no? Query input, search input dot value, and then const rankings is going to be equal to, oh, and I just wanted to change one thing. Sorry, I forgot one thing that I wanted to change here in the rankings, because if you remember when we did our rankings before, so they came back from bottom to top. I want them to come back the other way, so I'm just going to switch B for A here, so that the top result is closer to the beginning of the array, because that just makes more sense in terms of displaying it. Sorry, I forgot about that. And we're going to say rankings equals to await, compare, and we're going to pass in our query. And we also need to get our database. So what we could do is, we don't need to get the whole database every single time we run a search, because I'm assuming here that this is a database that is not constantly changing. If it's a database that changes often, then you're going to have to think of when you're going to want to refresh this data. But for the sake of speed, I'm going to query this database once when the page loads. So let's create a new function here, const load data, and this will obviously be async. And what we're going to do, I'm going to say here, let data, and I'm going to say const database query equals query result equals to await wix data dot query, and we're going to query the vector database dot find. We're getting everything there. And I'm going to say that this will say that data equals to database query result dot items. Okay, so we're getting this data as soon as we load the page. I'm going to go load data. And then here, I can just pass in this data, and it should already be available to us once somebody is searching. We could also add some UI elements to prevent searching before the data comes back or something along those lines, or query for the data if it's not present. So like I can go here, like if no data, await, something like that, just to make sure that it happens. Or I can even put an await here, so this wouldn't work before the data was loaded. Anyway, there's different ways to solve this. And we get back our rankings, and basically what we want to do is just assign these rankings to the repeater. So um, results repeater dot data will be equal to these rankings. And I'm going to just add a little UI magic here, UX magic. I'm just going to collapse this and expand it when it comes. Okay, I think that that should be good. Let's give it a spin. So I'm going to go ahead and go into preview mode. And we don't have our repeater. Excellent. So again, we're looking for products. So I'm just going to say here, I need a way to charge my phone. And go ahead and search. And let's see if we have any errors. All right, 0 of undefined. Embeddings line 37. Cosine similarity, query vector. Okay, so that means that there was, oh, this needs to go here. Excellent. And let's try that again. So I'm going to go ahead and preview. And I need to charge my phone. So first thing we got was a portable power bank. Obviously, this is like over. UI here is terrible. The results are completely on the top of my search bar. Electric toothbrush, wireless headphones, smartwatch, and air fryer. So in terms of the results that I would expect, definitely portable power bank is what I need for charging my phone. And we found this even though word phone doesn't even exist here. This sentence doesn't exist here inside of power bank. So this is a really, really powerful search. Let's try another one. So let me just fix this so that pop up over the, so I'm going to put these in a container and I'm going to put these both, stack these. Hopefully that'll prevent the issue. And now we can do multiple searches without refreshing the page. Okay, search query. So my teeth are very dirty. Search. Okay, first thing I get, electric toothbrush. That's exactly the result I would expect. Wireless headphones maybe could be used kind of as a form of dental floss, I guess. Yeah, I guess if these are really not similar at all, let's just try another one just for the fun. Um, I want to cook chicken and go ahead and search. And the first thing that comes up is air fryer. So I am super happy with these results. I think that this is a perfect demonstration of why semantic search is so powerful. And yeah, I hope you liked this video. If you did, don't forget to like and subscribe, and I will see you next time.